Differentiation is the process of calculating the gradient of a curve at a specific instance of x value.
Got it.
Good. Did you completely master the concept of tangent in previous lesson?
Yes, I did, teacher. Let me recall for a quick moment. A tangent is a straight line that meets a curve at a point and carries on without crossing to the other side of the curve at that point. And that point is said to be a point of contact.
Absolutely. And at that point of contact, the gradient of the tangent gives the gradient of the curve.
So calculating the gradient of the tangent gives the derivative of the function. And how do we find the gradient of the tangent at that point?
This is what we are going to learn today. Let me show you some geometrical interpretations. Suppose a curve y equals f of x is as such. Let A be any point on the curve, where we want to find the gradient of tangent. Let B be another point on the curve that is fairly close to the point A. Now, it's obvious that the gradient of the chord AB will give an approximate value for the gradient of the tangent at A. As we move the point B closer and closer to A, for example, B1, B2, B3, and B4, then the approximate value for the gradient of the tangent at A gets more accurate. In other words, if point B approaches very, very close to point A, then the gradient of the chord AB will be approximately equal to the gradient of the tangent. Hence, the gradient of tangent at point A simply gives the gradient of the curve at that point.
Could you be more specific with an example?
No problem. Take a look at this example. For curve y equals x squared, point pxy will be equal to pxx squared. Let's have point Q on the curve, which has the x-coordinate x plus h, where h is a small increment. The coordinates of Q will be x plus h squared. Now find the gradient of the chord PQ. Since h is a small increment and if point Q approaches closer to the point P, then the value of h also becomes very, very small or shrinks towards 0. Then the gradient of PQ tends to become 2x plus 0 equals 2x. This is the gradient of the tangent at P. So you can also say the gradient of the curve y equals x squared at the point xy is equal to 2x.
Oh, so that's how it works. It's not that difficult.